thing are inverses. Put in the first one up there.
You don't write the point.
You can just do the sketch. Go ahead and put the original on there just so you can see that. Alright, ready? Can you squeeze over on the other side? Here's right. Make sure it's on video. This part doesn't have it. Definitely, can you step aside and let Cole through there? If you can draw the original, that would be great, but just so we can see the relationship. And it doesn't have to be perfect. I know it's hard on the board when we don't have a grid. So Declan started with a parabola opening up. And the inverse then was a parabola opening sideways, which makes perfectly good sense because in the original it was x squared. We were squaring our x's. In the inverse then we're going to be squaring the y's. Notice that the original for Declan, the original was a function, but the inverse is not. Everybody okay with Declan's? Can you?
I realized as I finished.
Can
Still
you
looks cool.
see?
You just lost something.
Kind of. I'm gonna swerve it there a little bit.
Looks
Can
cool,
you
though.
see the identity line in there?
Not a lot. A little bit.
It's hard without the grid. Okay, and then we have this.
I realized I messed up as I finished.
Well, I don't know. Yeah.
This is deplorable.
Yeah. I think you did mess up. Okay, so here's how we can tell. Cole, take a look up here for a second. Cole, look. There are a few points. Yours is a little harder than his was, but there are a few points that we actually have on the graph. One of them is right here, -2, 0. So where should that point be plotted in red then? If the blue point,
-2y? Okay.
So if the blue point is -2, 0, then your red point is going to be 0, -2.
Yeah, okay, that makes
Okay.
sense.
So this, I don't know how to describe it, this kind of big hill here is actually going to be down here now, and not over here. So another point you have on your graph, for sure, well, you got 0, 0. And then you have 1, 0, which will be plotted as
0, 1.
0, 1. So these are going to be connected like that. Let's see. Okay, these are going to be connected like that. So you get something that looks like this. So you have the right shape You just had to kind of whopper jaw it in terms of the size. All right, everybody okay? Graphing inverses? Okay. What do inverse functions do? For example, if we plug a 2 into the function, we get 5. But if we plug 5 back into the inverse, we should get 2. Right? So if in the original, we talked about this before, I can't remember, I think we were doing transformations. If f of c is d, then f inverse of d will be c. The ordered pair c comma d becomes the ordered pair d comma c. That's what it means to be an inverse. All right, two functions are inverses if and only if f of g of x is x and g of f of x is x. So in other words, the compositions both equal x. This is how we prove. And this is an important thing to know and to be able to do. So somebody has told you that f of x equals 2x minus 3 and g of x equals 1/2 x plus 3/2. Somebody's told you these are inverses. And your job is to determine if that's true, prove if that's true. So the first thing you're going to do is build one of the compositions. So I'm doing f of g, we're going to do both of them, so it doesn't matter which one you do first. So f of g of x. So that means take g and plug it into f. Right, everybody remember that from yesterday? So we're going to take the g function and we're going to plug it in for the x in f. So we're going to have 2 times 1/2 x plus 3/2 minus 3. All right, let's clean that up. Oh my gosh, what did we get? X, which is exactly what we started with. That was our original input, was x. Good. Now do it the other way. So now do g of f of x. And you have to do both. It's not negotiable. You have to do both. So take f and plug it into g. So 1/2, we're taking f, plugging it into g. So 1/2, 2x minus 3 plus 3/2. Clean it up.
They're inverse. Do we know what g is?
That's the proof. That's the proof. Nothing else you do is going to constitute a proof, so don't try to shortcut it, don't try to do other things. That's how you prove if things are inverses. Now, let's suppose we did this one, and it came out to be x plus 1. Then we could stop right there and say we don't have an inverse. Because if you have an inverse, both compositions are going to equal x. This one didn't, so I would just stop right there. There's no point doing the other one. Okay? So, would you do example 7?
how do you know that it's not negative x?
That's a great point. When the radical is already in the problem, it has whatever sign it has. So this is a positive radical. It is only when you're solving an equation, like you have like x squared equals 9, there is no radical in that equation. You put one in, when you put it in, then you determine the sign. So it would be plus or minus. Does that make sense to you? Okay. All right. So did everybody get that okay? Those are inverses of each other?
What was like the x is greater than or equal to 10?
What was that? Why did they put that in there? X greater than or equal to 10.
To throw you off.
You can have a negative of it.
They did. I have a negative square root.
Excuse me, my stepfather just passed away.
Oh,
Sorry.
sorry.
Yeah.
He's raised me, he's been part of my life for over 60 years. I saw him on Thanksgiving, he was not well. He did not know I was there, but I knew I was there.
I'll pray for you.
It's a great circle of life. In 2 days, day after tomorrow, my daughter-in-law is gonna have a new baby, so we have a new baby coming in. And my dad moving on. Okay, all right. Did someone ask a question before I did that? I can't remember.
The x
Oh, yeah.
greater than 10.
Yeah, x has to be greater than 10 because why?
There can't be a negative on it.
Yeah, otherwise the problem wouldn't even make any sense, right? This won't even exist. We can't even think about that problem unless we know that x is bigger than or equal to 10, right? Okay. All right, so would you do example 8? I'm gonna go ahead and let my children know. Would you go ahead and, do that last one? Okay, when you start putting these complex fractions in here, things get a little bit, crazy looking, but it's easier than you think. So first of all, did you build the compositions at a P and P of N? So this is going to go away, so we're going to have 6 over x, which is 6 times x over 6, isn't it?
Yeah.
Which is x, so that one worked out. Now this is a bit of a mess. This is, just this part, is 6 times x minus 4 over 6. Which is just x minus 4, but you still got that plus 4, so that one worked out too. Right, Declan?
On the top one, why is like the complex fraction 6 times x over 6? You just,
As opposed to what?
well, I don't know.
This
I've
is
never
6 divided by 6 over x.
Oh, okay.
And how do we divide fractions?
What?
Yeah, multiply by the reciprocal. Yeah. You could also, if you wanted to, multiply everything by x. So you'd have 6x over 6, which is the same as x. That's another way of dealing with those.
I missed the part where you were explaining, I think you were explaining why it says x is greater than or equal to 10. But is it the same thing where it's like x can't equal 0, x
Exactly.
can't equal 4?
Yeah, because
Why
if
is that?
x were 0, could you have 6 over x?
No.
No. So it's a domain restriction. They're just covering their bases so that the problem can be. Because it can't be if x is 0, the denominator is 0. All right, so let's go to the back of the next page, check your understanding. All right, number one, based on the table, do you know what what G inverse of 12 would be? Now think about that for a second. Yes, I heard somebody say it. If we're looking for G inverse of 12, we want to know what does that equal. I'll just call it C. Doesn't that mean that G of C had to be 12? So what is that number? What gives you 12 in the chart? It is 16. 16. Remember the ordered pairs flip-flop. All right, can you find, in the picture, can you find H inverse of 2? Same logic. H of something equals 2, right? So H inverse of 2 will equal that something. So what gives you 2? So small. 5? Everybody okay with that? If you put in 5, you get 2. So the inverse of 2 will give you back 5. All right, so here's our formula for finding the Celsius temperature from the Fahrenheit temperature. Go ahead and find the inverse. Find the inverse of that. What'd you come up with? Did you guys, like, when we were younger, didn't we have to memorize these formulas? For some reason, I think I remember having to do those. What was the Fahrenheit one? What's the inverse one?
You switch the
9/5 C plus 32. So the original takes Fahrenheit and changes it into Celsius, and this one takes Celsius and changes it into Fahrenheit. Alright, number 4, the distance in miles and minutes to travel. Okay,
Is the 32 in parentheses?
no, I don't think so.
I was just wondering why the 32 is in the parentheses for itself.
Because if you multiply by 9/5, multiply both sides by 9/5, you have this. And then to get f by itself, you just add 32. Okay, so f of x is the distance in miles that an ambulance can travel within x minutes. So this is minutes, and this is distance. So what would the ordered pair f of 20 equals 26 mean? What does that mean? F of 20, this is f, regular f. In 20 minutes, we can go 26 miles. So if I turn that around, it'll say this. And what does that mean? It's gonna take me 20 minutes to go 26 miles. If I have 26 miles to go, it's gonna take me 20 minutes. This says if I have 20 minutes, I can go 26 miles. If I have to go 26 miles, it's going to take me 20 minutes. All right, go ahead and do number 5. Find your own inverse and then prove that you're right. Find your own inverse and prove that you're right. All right, so these are gonna be a mess to clean up. So before I get too far into all that hideousness there, let me make sure that I did this part right. Did anybody else get this for the inverse? Okay.
Yeah.
Okay, then now what we're gonna do is build the compositions using this original function and this inverse that we got. So my top one, and again, you do those in either order, my top one says, I'm gonna take my inverse and plug it in right here. So that's what I did. I took my inverse and plugged it into my original. And then the other way says, take the original and plug it into your inverse. So that's what I did right there. Now, does anybody have a question about that? That's messy. All right, let's clean it up. You can do whatever you want here. This is a mess. I think I'm gonna multiply everything by x. That'll get rid of that and leave me with x over 1 minus 2x plus 2x. Oh, that was nice. So x over 1. And I think here I'll play the same record. I'll multiply everything by x plus 2. So I'll have x plus 2 minus 2 over 1. There we go. That could find its way into a free response question. Somehow finding an inverse and proving you're right. Remember, the free response questions have like 12 parts to them. So that could be part of one. You okay with that? All right, we're gonna do one more page here. Go to the back of the next page. And I want to use a vocabulary word I don't think I've used yet, and that is one-to-one. We have noticed with what the boys graphed earlier, especially, that that you can have something that's a function. That's a function. But its inverse is not a function. There are other things that are functions, and the inverse is also a function. Can you think of a shape, maybe, that would work for, Al?
Lines.
What?
Lines.
So Al says take a line, like maybe, here, I'm gonna put my identity in there. But let's take a line, or like, oh, we'll take this one. What would the inverse of that line be? Wouldn't it be this line right here? Reflection across the identity? Are both of those, no, not together, individually, is that a function? Yep, and that's a function? Yep. When that happens, when the original and the inverse are both functions, the function is called one-to-one. Can someone explain that vocabulary? It makes perfectly good sense. Think about that for a second. What does it mean to be a function? It means none of your x's repeat. How do you find an inverse? You switch the x's and y's, right? So if none of the x's repeated in the original, then none of the y's will repeat in the new one, right? But if the inverse is also a function, then the original y's didn't repeat because they became x's in the other one. So in other words, 1x, 1y, nothing is repeated. No x's are repeated, no y's are repeated if something is one-to-one. Furthermore, if you're one-to-one, I want you to think about this parabola right here. This parabola has repeated y values. It's a function, but maybe this is 2 comma 4 and this is negative 2 comma 4. So what happened when you flipped the ordered pairs, you had 2 points that had the same x value, right? If something doesn't pass the horizontal line test, then it can't be one-to-one. Because if it doesn't pass the horizontal line test, it means it has repeated y's, and one-to-one means you can't have repeated anythings. So how do you tell if something's one-to-one? It's gotta pass the vertical line test, and it has to pass the horizontal line test. So think back to your BFFs. Lines are perfect examples, as long as they're not vertical or horizontal. Think about your reciprocal function. Remember this guy? Is he one-to-one?
Yeah.
Yeah, because he passes the horizontal line test and he passes the vertical line test. Okay? So, I want you to work on 1, 2, and 3. And then I got a worksheet for you, we'll do a little extra practice. Let's get 1, 2, and 3 done. Talk to your friends.
Yeah, but that's what we got.
That's scary.
You start in winter, you end in winter, you go summer, and then just peak it. I guess it would, the question there is, who would learn how to content? Because temperatures
What have you decided about number 1? No? Why? Why number 1 now?
temperatures can repeat.
Temperatures can repeat. Would you agree with that, that over the course of a year, you can have the same temperature more than once? And remember, if you're 1 to 1, nothing repeats. So the days won't repeat. I mean, you have just one, January 8th, but that temperature could be repeated on another day. So you're right, very good. Okay, so that means the inverse is not a function, okay. What does the graph of f of x look like in number 2? What is that? What shape is that? A parabola, opening, be careful, it's opening up. It's x squared. X squared's open up. But it's positioned 3 units to the right. Would you all agree with that? Is its inverse a function? No, because this does not pass the horizontal line test. It's a function, its inverse is not. Okay, here comes the tricky part. Could we restrict the domain so that the inverse is a function? So right now, the domain of this function is everything, right? Could we restrict that? Now, restricting it will change that picture. But could we restrict it so we are 1 to 1?
When x is greater or equal to 3.
Okay, so he says, let's restrict the domain so x is greater than or equal to 3. If we do that, then the only part of the picture we have is this. Would you agree with that? And that is 1 to 1. that passes both of them. Now keep in mind that the inverse of the original would have been this parabola, right? Everybody okay with that? But as soon as we did that, now we only have that, the top half of the parabola, and that is indeed a function. Good work. All right, were you able to find the inverse of this one? Did you get this far? I got x squared plus 4. Well, we have to talk about that, so let's just pause here. Just doing the arithmetic, this is what I got. Does that look okay? Yeah?
Yeah.
Okay. Now let's talk about what's wrong with it. What's this look like? That's the original problem. What does that look like? What's the square root look like? Right, up and out. But it's been moved 4 to the right. So would you agree that is the original picture? Okay, now let's look at what this looks like. What's this? Parabola, 4 units up. Looks like that. Kids, they don't match up. Remember, I'm supposed to take the ordered pairs there, flip-flop them, and get this. Aren't there too many points down here? Isn't this picture too big? So what do I have to do?
Restricted?
This domain is restricted to x bigger than or equal to 4. Would you agree with that? And y is greater than or equal to 0. That's the original domain and range. Well, what happens when I do the inverse? X and y switch. So what should my domain be? X is bigger than or equal to 0. And my range is y bigger than or equal to 4. So this is the inverse.
Why is the range of the original y is greater than or equal to 0? Because couldn't you still have a negative? Like,
How can you have a negative?
like in the original, the x minus 4 into the radical, couldn't that root be a negative? That y could equal a negative?
I don't, so you mean like if there's a negative out here?
If
There isn't. This is a positive. Your y's are going to be positive numbers. This is a positive square root. So every value that comes out of this is going to be positive. X is going to have to be bigger than 4, so nothing's going to be negative under here. And then all the y's that come out are going to be positive numbers.
I was just thinking, couldn't like negative 8 be the square root of 64?
Okay, but then, this goes back to what I told Alex. When you see this symbol, it has a sign attached to it. And the sign attached to it is positive. There is no negative option when the problem is written for you already.
Alright.
The only time there's a negative option is when you have that, which there's no radical in that problem, but you put one in to solve it, then you've got an option.
Alright.
When you put the radical in, but when it's already part of the problem, it's built. So Declan, we could just as easily have had that. Well, that wouldn't be the top half of the parabola, it would be the bottom half of the parabola, but the negative would be built in. Okay, just like the positive is built in. You also definitely need to rely a little bit more maybe on your picture to help you out, because you already know what a square root looks like, right? And it does not have any negatives, unless it's been vertically translated. Okay, so the important point here I wanted to emphasize is we have our original domain and range, and they correspond directly, flip-flopping, with the domain and range of the inverse. That has to be the case. All right? Well, thank goodness for Mr. Passwater. Because he has come up with some practice exercises. Oops.
Got it in my GPA.
Password is low-key goat, password is Einstein. Low-key taking password. I'm taking password.
Me versus password. Street fight. You taking me?
Yo, me versus password. Street race. Right now.
All right, there's one side is compositions, one side is inverses. So let's look at the composition side first. And this is kind of like what we had in the notes, where we've got a picture, table, and a piecewise function. All right, so let's just, we don't have time to do all these, let's just randomly pick one. Let's start with 12. Let's do 12. That gets all three functions involved.
I don't even know what I'm looking at.
You're doing number 12 on the composition side.
I'm just like saying, it looks confusing.
It's not.
You can do it.
Find f of 12. F is the picture. What do you get if x is 12? -1. So now take the -1 and put it into G. G is your chart. You put in -1, you get 8. And then take the 8 and put it into your piecewise function. Just be careful. Where does 8 go in the piecewise function? Top, middle, or bottom? Bottom. So we have 2 to the 8, which is 256.
Yeah, that's what I got.
So the answer is 256.
Yeah, that's what I would have done.
All right?
I was with it.
So let me just randomly pick a couple more. Let's do 4 and 7 and 10, just for fun. 4, 7, and 10, and we'll compare answers. 4, 7, and 10.
Ooh.
Wait, what did you do? There's a whole 8. Yeah, when I can do it, just rarely find myself in this area.
It's pretty solid. We have a whole test just over this
Is
stuff.
there is? Well, we're gonna have to do this. Okay,
Pretty nice.
so number 4, what did you get? Number 4? -4? You gotta speak up or hold your peace, folks.
I got negative
-4.
Okay, Owen got it, we're good to go. Number 7,
Negative
Two.
two.
positive 2.
Who said -2?
It's
Would be me.
positive
Negative 4 Ripper again.
2. And number 10?
Negative 4.
Negative 4. Alright, flip it over.
Problems 4 through 10 are not a function. They're repeated.
So now we got inverses.
So drop our
For each graph below, sketch a graph of the inverse on the same, okay. So let's start with number 1. Sketch your inverse on your paper and then show it to your partner. And remember, you can sketch the inverse by simply flip-flopping the ordered pairs. Or if you wish, you can reflect across the identity line. Fred has the identity drawn on his paper, he's gonna reflect. You can also just flip the ordered pairs. And then compare your picture with your partner after you've had a chance to get it done. And let's make sure that we match.
That's fraud, dude. That's fraud.
Mine looks like. Okay, when you're done with number 1, you match your partner, yep, that looks good. You good? Okay, then let's do the second one. And then we'll probably be done. Now, inverse holes operate the same way as regular points. So if there's a hole at 2 comma 1, there is going to be a hole at 1 comma 2.
What's the exclamation mark?
I saw you. I saw Thomas.
Sorry, you're in.
In that second one, did one of your pieces end up being part of the inverse also?
Yeah.
Yeah. And why is that? Because it's on the line, like it was. All right, tomorrow, or next time I see you, we're going to review a little bit. And then we'll have our quiz. We'll also be moving ahead into the law rules.
Can you make this quiz worth like a ton of points?
I
Make this one worth 200.
randomly picked a number, I don't know.